Okay, what we're looking at today in section 6.3 is we're actually doing part one. We're only going to do long division today, and next class we're going to do synthetic division. All right, so what we're looking for when we do long division of a polynomial is we're looking to basically find different ways to find different factors of a polynomial. So what I want you to do first is push pause, and I want you to refresh your memory on how you do long division, because we're going to use basically the same pattern to do this. All right, so back to doing long division. If you remember what you did when you did long division is you looked at like each number and like you said, okay, 7 won't go into 3, so I got to expand it to 37, which 7 will go into. So I put a 5 right above the 37. 7 times 5 gives me 35. Then we always put a minus out there to get, and we got a remainder of 2. And then we brought down the next number, which was a 1. And then we looked at it and said, okay, so that means 7 will go into 21 3 times. 7 times 3 is 21, so this time I don't have a remainder, so all I have is the 7 that I bring down. Well, 7 goes into 1, or 7 goes into 7 one time, and I have a remainder 0. So this basically is telling me that 7 here is a factor of 37/17. All right? And it's important to remember, it's because it has a remainder 0 that I know 7 is a factor. All right, so taking it to the next one. 11 times 2 gives me 22. Remainder 5, bring down 2. 11 times 4 gives me 44. This time I have a remainder. So this one would not, 11 is not a factor of 272 because this one has a remainder left. So it actually could be written as a fraction, 24 and 8/11ths. All right, so moving to the next one. 21 will go into 33 one time. Leave me with the 12 remainder. I bring the 7 down. And then, okay, how many times will 21 go into 127? Let's see, 6. Yeah, 6 times 2 is 12. 6 times 1 is 6. So yeah, 6 times. So again, this one has a remainder of 1. So it means 21 is not a factor of 337. Because this one would be 16 and 1 over 21. So this is the only one that was a perfect factor on number 1. All right. So we'll come back to that idea when we flip the page over and talk about factors on the back of the notes. So here is what we're going to do when we divide. I'm going to leave a little space over here on the left because we're going to write little notes as we go through it. So I put x minus 3 on the outside. I put x squared plus 3x minus 12 on the inside. What you want to look for is, look at the lead coefficients, the lead numbers on each one. So on the first one, what I want to look for is, what do I need to multiply this lead by to get this lead? So I think about, okay, if I take x times x, that gives me x squared. All right? So I'm going to think about this every time I start one of these. What do I multiply by x to get x squared? Question mark. So this time I wrote multiplied by x. So then what you're going to do is basically you're going to multiply x times x minus 3. So step 2 is basically we're distributing x times x minus 3. So if I do that, I get x squared minus 3x. So x times x gives me x squared. X times negative 3 gives me minus 3x. Okay, now this is where I need you to go back and think about long division up here. Every time we did one of these, we subtracted it off. We subtracted it off. We subtract off. We subtract off. Well, we got to do the same thing here. We're going to take this and subtract it off. So that means basically, for step 3, I'm going to subtract, which means once I distribute the negative, I change signs. So this is going to end up becoming a negative x squared. This is going to become a plus 3x. So x squared minus x squared leaves me with a 0. 3x plus 3x gives me 6x. So the only thing I have left to bring down is the minus 12. Okay. So then basically we brought down that negative 12. So then I want to look at it and say, what do I multiply x by this time in order to get 6x? I multiply by 6. So I have 6 here, because what I'm trying to do is this. 6 times x minus 3 to get 6x minus 18. Again, I put a minus in front and change all the signs. So 6 steps, change all the signs. So this becomes a minus 6x, this becomes a plus 18. So I'm going to circle it so it's easier to spot it. So minus, plus. So 6x minus 6x is 0x. Negative 12 plus 18 is 6. Now I want you to think about this for a second. When we did this, our whole goal was to make this step happen. We were trying to subtract off the lead term, 6x minus 6x. Just like on this one, our goal was to, that's why we multiplied by what we did, was to make that one, the x squared term, disappear. All right, so this is telling me, since there's nothing else to bring down, I have a remainder of 6. So here's how we're going to write this. X plus 6. And then think about how we wrote a remainder over here. We put the remainder over the divisor. So I'm going to put, since it's a positive 6, I'm going to put plus 6 over x minus 3. All right? All right, so let's try the second one. I have x minus 4 on the outside. I put the x squared minus 3x plus 1 on the inside. Now go back and look at what we did up here. What do I multiply x by to get x squared? Same thing as before. I multiply by x. And then over here, if you look at it, we distributed, so I'm going to do the same thing here without rewriting it out. X times x is x squared. So you see that's going to subtract off here in a second. X times negative 4 is negative 4x. I put the minus, I change the signs. Boom, changed, boom, changed. So I get, I don't know why I put that as a plus. Let me fix that, I'm sorry. Minus here, that was a positive to begin with. X squared minus x squared makes that 0x squared. Negative 3x plus 4x is 1x. Bring down the 1. Alright, so we're up to step 4 basically. I just brought down the 1. Okay, then we're back to step 5. What do I multiply that by to get that? Alright, so I look at it as positive 1 is what I want to multiply by. So I distribute 1 to x, 1 to negative 4, my minus, change both signs. So that cancels, leaves me with a remainder of 5. Alright, so this one would be x plus 1, remainder of positive 5 over x minus 4. Alright, so one thing I want to point out to you, just like up here, this was the only one that was a perfect factor, 7, because it's the only one that gave me a remainder 0. This was not a perfect factor because it gave me a remainder 8. This one wasn't a perfect factor because it gave me a remainder of equal to 1. So the same thing applies to this. I know x minus 3 is not really a factor of x squared plus 3x minus 12 because I have a remainder. Same thing happened down here. I know x minus 4 isn't really a factor of x squared minus 3x plus 1 because I had a remainder of 5. So basically, if I don't have a remainder of 0, it's not a factor, which is what we're going to talk about on this backside. All right, so whenever you're given these directions, determine if this is a factor of each polynomial. You're basically looking to see if, only if, the remainder is 0. So the only way that x plus 4 is a factor of this and this or this is if the remainder is 0 and I do the long division. So let's check and see what our remainder is. So if I have x squared plus 6x plus 8 inside, and I have x plus 4 outside, that means when I take this here and I look and see what can I multiply by x to get x squared, I say x times x gives me x squared. So I put my x there. X times x gave me x squared. X times 4 gives me 4x. Change both signs. Minus, minus. So 6x minus 4x gives me 2x. Bring down the 8. Now here's my lead. Here's my lead. What do I multiply x by to get 2x? The answer is positive 2. So when I distribute that, 2 times x is 2x. 2 times 4 is 8. Change both signs by putting a minus. 2x minus 2x, 0. 8 minus 8, 0. So what is that remainder then? The remainder is 0. So just like when I talked about this at the very beginning, 7 is a factor of 3717 because it has a remainder of 0. The same thing applies right here. So answering this question, on part A at least, yes, it is a factor. And I want to make a little note because the remainder is 0. All right, so let's try the next one. X cubed plus 3x squared minus 6x minus 7. Okay, I'll put x plus 4 up again. What times x will give you x cubed? Well, I need to get a third power. This is the first one we're doing a third power, so I got to take that times x to the second. And then whenever I distribute it, x squared times x is the x cubed I need. X squared times 4 is 4x squared. That minus changes both signs again. So 3 minus 4 is negative 1x squared. So bring down the next. Okay, so again I go back and I look at this and I say, what can I multiply by x to get negative x squared? This time I need it to be negative. So this, again, this is the first time this has happened. This needs to be negative x, because I want this to be a negative times a positive gives me a negative. So when I distribute, negative x times x gives me negative x squared. Negative x times 4 gives me negative 4x. The minus changes both signs. So I'm just going to cross this one and circle it so I remember I changed it. Cross this one and circle it so I remember I changed it. Negative 6 plus 4 is negative 2x. Bring down the negative 7. So what do I multiply by this time to get negative 2x? I multiply that by negative 2. Negative 2x minus 8. So you can already tell, since there's nothing else to bring down, that this is not going to be a factor. So I'm going to change that to a plus, change that to a plus. I do have a remainder. I have a remainder equal to 1. So that tells me it's not a factor. All right. So same thing on the bottom. Example 4. What do I want to multiply 3x by to get 6x cubed? Well, I want to multiply 3 times 2, obviously. X times x squared to get x cubed. All right, so distribute it. 6x cubed. 2 times 4 is 8 x squared. Change both signs. Boom. Boom. I get negative 6x squared. Bring down the minus 11x. Back here again. What do I multiply 3 by to get the negative 6? Negative 2. What do I multiply the x by to get x squared? X to the first. So then when I distribute, negative 2 gives me negative 6x squared. Negative 2 times 4 gives me negative 8x. Change both signs. So I got a plus now. I got a plus now. Negative 11 plus 8 is negative 3x. Bring down the 12. All right, this time I multiply by negative 1 to get negative 3x. Negative 1 times 4 gives me minus 4. Change both signs. So my remainder is 16. So this one would not be a factor. Okay, so going to B. 2x minus 1 divided by 2x to the 4th plus 3x to the 3rd minus 4x squared plus x plus 1. I multiply 2 times 1 to get 2, but then I multiply x times x to the 3rd to get x to the 4th. So this one would be x to the 3rd. Two x to the 4th, x to the 3rd times negative 1 is minus x to the 3rd. Oops, change it to a minus, change that to a plus. So now I have 4x cubed, bring down the negative 4x squared. Alright, so that means now I'm going to multiply this by 2 to get 4, this by x squared to get x cubed. So I put plus 2x squared. So 4x cubed minus 2x squared change both signs. So I end up with negative 2x squared, bring down the x. I multiply by negative 1 to get negative 2. X times x gives me x squared. So I got minus 2x. Ah, my bad. It should have been minus 1x. So change it to minus 1x. 2x times negative x is negative 2x squared. Negative x times negative 1 gives me plus x. Change both signs. 0 plus 1. Alright, which basically is telling me there's nothing, only way I can multiply by that is have no constant term there, so it'll be plus 0, and then I have a remainder of 1. Alright, so this one would have a remainder of 1. So this one would look like x cubed plus 2x squared minus x plus 1 over 2x minus 1. And then if the question asks you, like it did up here, is it a factor? No, because of this. The remainder is not 0. Not a factor. All right, then the final type that you're going to see is, what do I do whenever it's missing degrees? And what you got to do is just make placeholders. It's like x minus 1's on the outside, x to the 4th minus 1's on the inside. But since there's not an x cubed, I got to put 0x cubed. Since there's not an x squared, I got to put 0x squared. Since there's not an x, I got to put plus 0x. And then I finally can put the minus 1, because I got to have every degree represented after I start with a certain degree. All right, so then what do I multiply x by to get x to the 4th? I multiply by x to the 3rd. So I get x to the 4th minus x to the 3rd. Change both signs. So 0 plus 1x cubed is x cubed. All right, bring down the 0x squared. Okay, this time I multiplied by x squared to get x cubed. So I put plus x squared. So we got x cubed minus x squared. Change both signs. So 0 plus 1x squared gives me x squared left. All right, so then I bring down the plus 0x. And I multiply x times x to get x squared, so that's what I'm going to put in the next spot. So I have x squared. X times negative 1 is minus x. Put the minus in front and change both signs. So 0 plus 1 leaves me with 1x, and then finally bring down the minus 1. All right, so this now it's becoming pretty apparent that if I multiplied this by 1, it will be a factor, because if I multiplied this by 1, it's the exact same thing as this. So 1 times x gives me x, 1 times negative 1 gives me 1. When I put the minus there, both signs change and give me a remainder of 0. So this thing's factor looks like that. So yes, it is a factor. All right, so that is using long division in order to factor down a polynomial.